Good morning, afternoon, or maybe even evening. My name is Mr. Wagner. This is the start of our third week of Algebra 2. Let's get to the good stuff. Hopefully your Labor Day weekend went fantastically. We're moving on Unit 5, Quadratics. Today's objectives and learning targets. Today we will solve quadratics using the square root method. We will know what a solution looks like in radical form and how to simplify said radical. So we have been doing in this class, we were solving quadratics last week via factoring. We're kind of adding another tool to that toolbox of how to solve quadratics. 5.3, this is solving quadratics using square roots. All this information can be found on our note link on the very first page of our Schoology. Let's get to the math. All right here. Solve this equation, x squared equals 121. If I wanted to solve this, let's see if I can bring my pen up. All right, starting off flawlessly. Here we go. The knee-jerk reaction to solve this right here is any number squared equals 121. So we want to square root both sides. We could do this when your x squared term is all by itself. It's isolated. There's nothing else on the left-hand side. Like previously when we were factoring, there was b and c terms, which made it difficult. You couldn't just jump straight to square root on both sides. But because your x squared is isolated, you can perform this operation. What you get is square root of 121, we can use calculators at this point, is 11. Now secretly, I'm going to graph this. This is not necessarily accurate. It's not wrong. The famous words of Bon Jovi, you're only halfway there. If I were to graph this, x squared, and I found out when it's equal to 121. You'll notice, scroll up. It does intersect my graph when x is 11. Right? These intercepts, when these graphs intersect each other, these are my solutions. Notice it doesn't only hit it once, it hits it twice. This happens two different times at positive 11 and negative 11. There's two solutions to this quadratic equation. If we go back and look at this, the reason why this is so, because every time you square a value, a number multiplied by itself, a positive and a positive multiplied by itself will give you a positive answer, but also a negative and a negative answer will do the same thing. If you were to plug in negative 11 to this equation, which here we go, if I were to say, for example, x equals negative 11, if I were to plug this into this equation, put your parentheses around that negative 11, negative 11 times negative 11 does equal 121. So the way we account for this fact is we always, every time we using this square root method, we tag on a plus minus. And that is my solution. The plus or minus isn't what that refers to. I have a lot of questions about this, even when we're in class. It refers to there being two options. It's not the fact that it's a special kind of answer. It's including the positive 11 and the negative 11. That's all that plus or minus symbol means. That you've taken both types of solutions. It's double the amount of answers. So make sure I would copy this information down right here. Or take a picture of it and copy it down. Or hit the pause button and copy this down because this is extremely important. When solving that's the bell, but you guys got to stay here. When solving quadratic equations using the square root method, make sure there are no b terms in your quadratic. I will get to this point very soon. Isolate your square term. Get it all by itself. You're going to square root both sides. Add your plus or minus to the constant to the right-hand side, and then simplify in radical form. What this means, there are no b terms in your quadratic. If I gave you x squared plus 7x equals 12, you cannot not use the square root method to solve this. That one would have to be factored, or another method which we will get to later. But this term in the middle, this 7x, we call that the b term. Because in standard form, ax squared plus bx plus c, this b term, I think attached to an x, not an x squared, just this first degree term x, you cannot solve using the square root method if that is present in your solution. But let's get to the practice. Boom. We're going to solve this equation. Notice it's a quadratic because this term is squared. There is no b term, right? There's no x values. It's just a constant and a constant. What we're going to do, step A, we're going to isolate our squared term. We got to get x squared all by itself. In order to do that, we're going to get rid of this 15. Boom, add 15 on both sides. What I'm left with, 49 plus 15 gives me a grand total of 64. Notice I put my x squared on my left-hand side. I will always be, whenever I'm solving this manner, I like having all my x values on my left-hand side no matter what equation I'm solving. So I will just be flipping that onto the left-hand side all the time. At this point, our x squared value is isolated. We can square root both sides. 64 is a perfect square of 8. Please note, it's both the positive version of 8 and the negative version of 8. That plus or minus symbol comes right there. Once again, that just means that there's two possible answers, positive and negative 8. We move on. Boom. This example, we notice we still want to isolate my x squared term, but now there's a coefficient, right? 82 minus 9. Ooh, let's make this a nicer number. Let's pretend that this was at least for now. Let's pretend that was 81, just for the sake of this example. 81 minus 9 is going to give us a grand total of 72. 4x squared equals 72. At this point, we still need to isolate x squared before you square root both sides. Divide both sides by 4. When you have that coefficient, we need to get rid of it. If you're multiplying, you want to do it by division. Left with x squared equals 72 divided by 14 gives a grand total of 18. Way I like thinking about that is we know that 4 goes into 80 20 times. And since it's 2 less 4s, it's 8 less than 80. It's 2 less down here than 20. That's where that comes from. From here, x squared equals 18. You'll notice 18 is not a perfect square, but this is totally fine. When we square root both sides, you're going to get x equals plus or minus square root 18. This is called radical form. Do not type this in the calculator. We don't want that. Anything in your calculator like that would be an estimate. It's a really good estimate, but it cannot be exact. This is an irrational number, but what we can do is reduce this. You'll notice this little guy down here, simplifying radical form. When we say things like that, what I'm asking you to do is pull out any perfect squares, which luckily 18's got a really good one. 9. When you're pulling out perfect squares, turn it into a factor of find your perfect square by factoring your original number. So 18 is equivalent to 9 times 2. 9, we can take the square root of. And where the square root of 9 is 3, you place it right in front with a radical symbol. The square root of 2 is stuck behind. You cannot take the square root of 2 and get a nice number. So my final answer, which these are equivalent, root 18 and 3 root 2 are the same value, just look differently. And that's my answer. Let me move on. Boom, right here, 2x squared plus 5 equals 77. I'm going to subtract 5 from both sides. 2x squared equals 72. I'm going to divide to get rid of my coefficient. 72 to cut in half is 36. This, we like 36. Because when I square root both sides, you'll notice I get square root of 36 is a whole number. X is both the positive and negative version of 6. Questions over this one? Sorry, you might have questions, but maybe this next example will answer those questions. We move on. This one, make sure we're doing the same exact process, but we are going to have to eventually divide by that -5. Do not drop that -5 during this. Once you subtract that 3, -9 minus 3 is -12. Just like this. Divide by -5 on both sides. What you're left with, x squared equals -12 divided by -5 gives me positive 12/5. This is a fraction. In this class, was for this section of the unit. Do not reduce these fractions, just leave them as is. Do not give me for this one, this would be 2.4. Please leave it as is. When you square both sides, you're going to be left with just that. X is equal to the positive and negative version of 12/5. For now, we're going to keep that right there. We're just going to leave that one as this is. Square root of 12 divided by 5. Positive and negative version of that. 2 more examples. This one has parentheses, which does not mean it is impossible to do. We're still going to apply the same methods. Isolating your square term, just my square term has something else inside of it. So we will not be done once I get rid of that, my square. Divide by 3 on both sides. X minus 2 quantity squared equals 7. At this point, this is where we square root both sides. We're left with x minus 2. Just make sure whatever's in the parentheses lives on. This is equal to my plus or minus root 7. Always make sure to tag that plus and minus in front. We're almost done. Isolate your x at this point by adding 2 to both sides. And when we're adding whole numbers to radicals, please put that whole number in front. The 2 comes in front. These numbers cannot be combined. Any whole number and radical numbers cannot be combined. Root 7 has no perfect square factors. And that is my final answer. Last example. 1/3 of x plus 5 quantity squared equals 7. We're going to solve this very similarly. But if you want to get rid of a third, you could divide by a third, which I would not recommend. Divide by fractions in general. It's the same exact operation, or you could get the same result if you just multiply everything by 3. 1/3 of 3 turns into 1. That's exactly what we want to do. Multiply both sides by 3. That's how you get rid of that 1/3. Multiply both sides by 3. You get 21 on the left-hand side. So 7 times 3 gives you 21. Square root both sides. X plus 5 is equal to the plus or minus version of root 21. Now, root 21 does not have any perfect square factors. I'm just going to continue on, isolate my x, put my whole number in front, make sure that -5 comes out front. That is my answer. X equals -5 plus or minus the square root of 21. last portion of this. Which of these equations below can be solved using the square root method, and which cannot, and why? I want you to hit the pause button for a second, ask yourself this question. One of these cannot be solved using the square root method. The other two can. Why and why not? So hit the pause, think about it. Which one cannot be solved and why? I hope you return. Basically, this third one right here, this is a b value. Because it's attached to that x term, we've been practicing all these, what we've been doing. The square root method cannot be used when you have a b value, which make this one unsolvable using the square root method. We can still solve that, just not using the square root method. I'm going to quickly do these other two real fast, just solve them for you. We're going to isolate our squared term by adding 6 and dividing by 4 on both sides. 48 divided by 4 is 12. You can use a calculator for this information. Just like I said, make sure we leave everything in radical form. I do not want decimals ever. This one, multiply both sides by 5. Left with x minus 4, quantity squared equals 6 times 5, which is 30. Square root both sides. X minus 4 is equal to the positive and negative version of root 30. Root 30, 4 does not go into it. That does not have any perfect square values. So I'm going to add 4 to both sides. X is equivalent to 4 plus or minus root 30. All right, last one we're going to do together. 10b squared plus 9 is equal to 769. We're going to subtract 9 from both sides. 10b squared equals 760. This is why we use the decimal system, because dividing by 10 is really easy. Just cancel out that 0. B squared equals 76. So when you square root both sides, b is equal to the plus or minus version of 76. Now, I do know that 4 does go into 76. The reason I know that is I know 4 goes into 80 20 times. So it goes into 76 1 less than 20, 19 times. We could pull out that 2 because the square root of 4 is 2. We're left with plus or minus 2 root 19. Please bring your questions over square root method into class and complete that homework of A5 over this exact information. Thank you. Enjoy the rest of your day.